In this video here, let's just do another problem reinforcing these very simple inequality expressions involving absolute value. So this should be similar to what we did in the last video. This should be a relatively short video as well. And I believe our prompt is almost identical to the last one. If x is an integer, what is the value of x? Except, so now in this case, instead of having just x under our absolute value sign, we have a more of an expression. Statement 1 says the absolute value of x plus 2 is less than 3. However, the fact that we have an expression here doesn't really change now. It doesn't change much because so before we said this means x is between -3 and 3. So now this is just telling us if I want to get rid of my absolute value bars, x plus 2 is between -3 and 3. And if I want to figure out what this is telling me about x, I just need to make sure if I want to subtract 2 from the middle here, I got to do the same thing to my left and right side as well. So just get x by itself by subtracting 2 from every side. This would mean x is greater than -5 and less than 1. Still gives multiple options for x. If x has to be an integer, x can be equal to -4, -3, -2, -1, and 0. 5 options, which makes this insufficient. Whoops. A and D can be eliminated. Statement 2, similar. Absolute value of x minus 2 is less than 3. So now, unlike the last one where we had a less than sign here and a greater than sign here, we have 2 less than signs. So this is still another between scenario, except here x minus 2 is between -3 and 3. So now if we want to get x by itself in the middle, we just got to add 2 to each side. This is telling us x is between -1 and 5. We still have multiple integer values that are possible for x. And like the first statement, we can write them all out if we wanted to. X can be 0, 1, 2, 3, 4. This again is insufficient. So now looking at them together, one thing you can do is if you wrote them all out like I did, is you can just find what these two boxes have in common. And it looks like in this case, the only one they have in common is 0. That is the only possible value for x. Therefore, together, it should be sufficient. The answer is C. Or, most likely, you won't have written them all out like this. And so in that case, you can do what we did. Similar thing to what we did in the last video and just sort of think about it. And so if we break down our left side extremes and our right side extremes from our two statements, sort of combine them. So on the left side, we know x has to be greater than -5, but x also has to be greater than -1. So what is that really telling us? Well, that's really telling us that just x has to be greater than -1, because that is the more restrictive of the two extremes. In other words, if you plot this on a number line, -5 is over here and -1 is over here. Well, if we're saying x has to be to the right of -5, and it's also got to be to the right of -1, well, really that's just the same thing. It's got to be to the right of -1. And then if we do a similar thing, the extreme values on our right side. So from our first statement, we know x must be less than 1. And from our second one, we know x must be less than 5. And so what is that telling us? Well, that's really just telling us it has to be less than 1, because in this case, this is our more limiting restriction. Because if x is to the left of 1, it's also to the left of 5. Well, this is really just the same as telling us x is to the left of 1. And so combining these two things together, we know x must be between -1 and 1. We also know it's got to be an integer. Therefore, x has to be 0 is your only option. So that's another way to get the answer as C. In the next video, we will look at another one that I would categorize in the simple absolute value categories, but we'll look at equations where we have to do a little bit more algebra.